I just paused for a second. I realized that I had not shown where 36.87 came from for the angles. So I'm going to stop talking about the moment real quick and talk about where those angles came from. So after I talk about it and show it, then I'll erase it so we have a little bit more room to play. But let's kind of look at it. I'm looking at, remember, DC. And member DC, I can find the angles in member DC. I know that the distance here is 9, distance here is 12. So this angle right here can be found using the arctan of 12/9. And the arctan of 12/9 is 53.13. Okay. That, by the way, I can find this angle where I'm drawing right now. That's the arctan of 9/12. Beautiful handwriting today. Let me start that part over again. The arctan of 9/12, which is equal to 36.87. I could have also done 90 minus 53.13. Okay, so now, all right, so let me get a couple other drawings in here. So here is point C. And this is the reaction at point C. So remember we said that was a 90-degree angle to C. Okay. So that's the reaction at C. That's a 90-degree angle to member BC. I was going to draw a dashed line. See how it works out here. So pretend like this is a straight dashed line. Okay. Let's follow along. The angle that I am putting a star by is 53.13, or the asterisk. It is an alternate interior angle to the angle I'm now starring, also 53.13, which is a vertical angle to the angle I am starring again, 53.13. So if you need to pause the video to kind of visualize and work that out, why it is that, you can. I'll pause for a second while you do that. Okay, I've unpaused. Welcome back. If this starred area right here is 53.13, then this angle right here is 36.87. Okay, 36.87. I'm trying to find, we did all that, by the way. In order to find the X and Y components of our reaction at C. So here's C. This angle theta is 36.87. That means that this is C times cosine 36.87. So that's the X component of the reaction at C. And the Y component of the reaction at C is C times sine 36.87. All right, I'm going to erase this so that we have room on the board to finish the problem. You can relook at this by rewinding the video as you need to. All right. Now, as a reminder, I went back to that because I forgot to tell you where we got the angles from. We needed that angle in order to calculate moments. So we are headed back to the moment equation. And we were taking the moment about point A. All right. So if we do the arithmetic, that's a negative 162 kip feet. Uh, 18 times the sine of 36.87 is 10.8. 10.8 times c. And 12 times cosine of 37 or 36.87 is 9.c. $10.8 plus 9.6, 19 is probably something like, gosh, I hope it's 20, so that's 19, 20.4. See? Add 162 to both sides. To both sides by 20.4, and we get that C is equal to 7.94 kips. And just so that we have it, because I think that we might need it, that would make CX equal to, well, to get CX, it's 7.94 times I lost my spot. 794 times cosine 36.87, which is equal to 6.35 kips. And CY is equal to 7.94 times the sine of 36.87, which is equal to, you guessed it, 4.76 kips. All right, from there, we ought to be able to get the rest of our stuff, right? So we still need the reactions at AX and AY. Summation of x's in the x direction, that would be equal to AX plus 15 minus 6.35 kips equal to 0. That means we get AX plus 8.65 kips equal to 0. Subtract 8.65 from both sides. AX is equal to negative 8.65 kips. Oh my, the negative sign. So as a reminder, the negative sign doesn't mean the force is negative. It just means that the direction that I assumed at AX is incorrect. So I'll go change that real quick. We now know that the reaction at A in the X direction is to the left. And our last one, summation of the forces in the Y direction. That's equal to AY minus 18 kips plus 4.76 kips is equal to 0. AY minus 13.24 kip equal to 0. Add 13.24 to both sides, and you get that the reaction at point A in the Y direction is 13.24 kips. I'm going to pause a second, update our whiteboard. When I unpause, the whiteboard will be cleaned off. I'll have the values for AX and AY annotated and for CX and CY annotated. See you in a couple seconds. All right, I'm back. So as promised, I've updated the reactions at point A and point C, and I'm ready to go down track. So the problem statement are to calculate the forces internal to each of the members. The process was to first find the support reactions to the supports at point A and point C. The next thing we need to do is we need to pick a joint where there are two or fewer members that we don't know the internal forces. I'm going to start at point A. Starting at point A, I'm going to draw my free body diagram for point A. And at point A, we have AY, we have AX, we have AD, and we have AB. So AB, AD, AY, which we know is 13.24 kips. AX, which we know is 8.65 kips. And we are ready to go. Taking a look at this. Taking a look at this. We'll look at forces in the Y direction. Oh, wow. So we have an angle, or remember AB is at an angle. The angle is 53.13. Go ahead and kind of quickly draw what's going on there. 53.13. I got 53.13 from the inverse tangent of 12 divided by the inverse tangent of 9. So if this is AB and the angle is 53.13, then the x component would be AB times the cosine 53.13, and the y component is AB times the sine 53.13. All right, so that kind of sets me up. All right, so I assumed that AB was going up. That means the x direction is going from left to right and the y direction from top to bottom. So I've got 13.24 kip. I'm looking at forces that are going in the y direction. Yes, plus AB sine 53.13 is equal to 0. Subtract 13.24 from both sides, we end up with AB sine 53.13 is equal to a negative 13.24 kips. Divide both sides by the sine of 53.13, and we get that AB is equal to negative 16.55 kips. So the negative sign indicates that I have AB drawn in the wrong direction. I assumed it in the wrong direction. So I'll erase that and correct it. Now I have it correct. So I'll put down here. So, all right, so I'm noticing that the arrow in the corrected version, the arrow is pointed into the point or into the joint. We said yesterday in yesterday's lesson that a force going into a joint is considered to be in compression. So AB is at a force of 6. Oops, that's not even close to being a number. So remember, AB is got an internal force of 16.55 kips, and it is considered to be under compression. So remember, I changed the arrow to go in. I had the arrow wrong, as indicated by the negative over here. We drew it. The arrow is pointing in. The reaction at that joint is toward the joint, which indicates that the member is in compression. In compression. All right, let's take a look at in the summation of the forces in the x direction. We've got negative 8.65 kips plus AD. This would, in the corrected version, the X component of AB will be negative. So minus $16.55 cosine 53.13 is equal to 0. Negative 8.65 kip plus AD. Very quickly, let me calculate that out. So negative 16.5 cosine 53.13 is equal to negative 9.93. Combine those terms, they're alike. We get negative 18.86 kips plus AD is equal to 0. Add 18.86 to both sides, and we end up with the member, or force in member AD is equal to 18.86 kips. Notice that that is positive. That's an indication that I'd made a very good, awesome, fantastic guess in the whether it was that member was in compression or tension. I have the arrow going away from the joint. From yesterday's fantastic lesson, we know that that means that's in compression, or I'm sorry, in tension. So 18.86 kips in tension. So right now we have AB and AD complete. I'm gonna pause the video a minute so that I can clean off the board. I'll see you in a couple seconds. All right, I'm back. I was thinking what we would do next is we'd go over to point B. Point B. We have to pick a joint where there are only two unknowns. We have calculated the tension in member AB. We don't know BD and we don't know BC. So there are two unknowns there. We'll start with the free body diagram. So AB was in, oh, I guess I could use the cool tool here. All right. So AB is in tension, so it's AB is in compression, so it is going into the point. I'm going to say that B, my guess is that BC that way, and I'll also guess that BD is this way. AB 16.55 kip, BD, and this one here was BC. Looking at the triangle for AB, so I have a visual. So this is AB. This would be AB cosine 5313. Cosine 53.13. So that's the that piece in the X direction. ABY is AB sine 5313. Substituting our known value for AB, which is 16.55. 16.55 times the cosine of 53.13 is 9.93 kips. And for ABY, again, 16.55 times the sine of 53.13 is 13.24 kips. Taking the summation of the forces in the X direction, we get 9.93 plus BC equal to 0. BC is equal to negative 9.93 kips, which is an indication that I have got BC headed in the wrong direction. I'm gonna go fix that. With the arrow fixed, I can say with complete confidence that BC is in compression. Remember, the arrow pushing or the arrow going into the joint indicates that the member is in compression. 9.93 kips in compression. In the Y direction, we've got ABY, which is 13.24 kips. Big surprise. It looks like I guessed the direction for BD is also incorrect. BD is equal to negative 13.24 kips. That indicates I have the direction for BD. I actually have a issue in my annotation. This should have been subtracting BD because I have BD showing going in a downward direction, leaving it really with negative BD is equal to negative 13.24 kips, which means that BD is 13.24 kips. Brandon, that means that I actually got the direction for BD correct. 13.24 kips, where that is in tension. The reaction is pulling away from the pin, which means that the action of the member is going into the pin. So that member is in tension. I'm gonna pause the video for a second while I erase the board. I'll be right back. All right, looking at my looking at our table over here, our scorecard, looks like the only thing we have left is to find the value or the internal forces of CD. We can pick, we have a couple choices, right? I mean, we could choose either point D or point C to do that. I'm just going to choose point D. I don't really have a reason. It's just what I did on my paper. So point D, a couple forces coming from point D. That is AD. That is DB. Oops, that was a mess. All right, there we go. CD, 15 kip force, and the 18 kip force. Let me take a minute to get everything labeled. All right, AD. AD was 18.86. DB is 13.24. CD is one that we're looking for. 15 kips we were given that. There's no way I can mess that one up. And 18 kips we were given. Just as a reminder, here's CD. CDX. CDY. This angle is 5313. So CDX is going to be CD cosine 5313. CDY is CD sine 5313. Okay. Well, we either take it in the X direction or the Y direction. I think on my paper, I've done it in the X direction. So if it's all right with you guys and gals, I'll go ahead and do it that way. Summation of the forces in the X direction, negative 18.86 kips, plus 15 kips. So if I have CD going up, that means CDX is going in the positive direction. So that'd be plus CD cosine 5313 degrees, all equal to 0. Combining those terms are like negative 3.86 kips plus CD cosine 5313 is equal to 0. Add 3.86 kips to both sides. CD cosine 53.13 is equal to 3.86 kips. Divide both sides by cosine 5313 and we get that CD is equal to 6.13 kips. It is positive, which means I have the assumption in the correct direction, have the reaction at the joint due to member CD pulling away, which means that the reaction, or which means that since it's pulling away from the pin, that the force is in tension in that member. So 1, 3 kips. Well, I'm going to have to erase to get it all to fit because I can't write on. As it turns out, you have to stay on the screen to write. 6.13 kips. So 6.13 kips in tension. All right, looks like that we have calculated all 5 internal forces. We have gotten the reaction forces, and we have the forces listed in compression or tension. So those were our 3 responsibilities, if you remember back from the last lesson. All right, I'm going to prepare myself mentally for the next lesson. I'll see you guys back in a little bit.